In this video I'll show you how to build a LED panel for a green screen studio. And I'm starting with a piece of aluminum which is 10 cm wide and the length is 1.80 meter. And we also need a piece of perspex which is again 10 cm by 4, and the thickness of this material is 3 millimeters. Again, this is a perspex which I cut from a big sheet that I had. We need 2 of these. We'll start by putting it in this place and taking a 3 millimeter drill and drill 2 holes in the perspex. Now we need to make the hole in the middle of this piece, so of course since it's 4 cm wide, then the middle will be 2, so I'm marking it here in both sides, as this panel will cover up the connection that we'll do with all the wiring, so it will be covered and will look nice. Next, we need to take the 2.5 mm drill in order to make the hole inside the aluminum sheet, because we want to make a screwing so it will fit the device that we're going to put here. So again, it's 0.5 cm less than what we need, since we need 3. And now after that you will see that I'm using first of all drilling all the way. That was just the marking. Now after of course we'll drill it, we need to make the screwing inside this aluminum using a thread screw, and which is number 3 of course, and making a thread inside the aluminum sheet so it will fit our screw, which is in this case a socket for a screw which elevates the whole thing above, so it will be easier to cover up it with the perspex, because of course all the wiring takes place, so we need spacing. After we put it in, of course I'm making sure that all our measurements are right and it's fitting the place, so we can continue our build. And now I'm taking the 5 mm drill in order to drill a hole inside this aluminum in order for us to be able to mount it to the ceiling. So I'm drilling exactly in the middle, since it's 10 cm wide and it's of course 5, and every 50 centimeters I'm drilling a hole, so it will be in that, I think if not mistaken, about 5 holes altogether. After drilling the holes inside this aluminum, of course I'm taking a big drill in order to cut off the edges of this drilling. So this is I think an 8 mm, just to clean up so it won't cut anyone or us when we install it on the ceiling. Next step, I'm taking a sandpaper number 0 in order to sand a bit this aluminum panel, which is of course came with paint, white as you can see, and it's very smooth, so we want to make it a bit rough so the LED will stick to it. So I'm just a bit of sanding and then of course cleaning with wet towel, just easily as you can see, and of course after that with something dry so it won't be wet. The LED I'm using for this project are 90 plus in the CRI value, and this is daylight, as you can see, 6000 Kelvin as in the color temperature. And of course, as you remember if you saw my other video, my favorite silicone is the Polymax, which will help us glue this LED strip to the panel. Of course the LED strip comes with double-sided tape, but of course just to make sure it will hold even when it's getting hot, I'm using the Polymax, and again cutting in the place that it marked with scissors and putting the Polymax, a very thin amount of Polymax, to the aluminum sheet. And after that of course we can peel out the protection on the LED strip and start taping it. As in all my videos, I will cut here a bit of time because you don't need to see me gluing everything, otherwise it will take a long time. In the meantime, I can tell you that we are now building an extra light for an already built studio which I built. The whole studio is a green screen studio, and it's all been LED with these LEDs. It has an option there currently for a bicolor, so it also has a daylight as we're adding now, and besides the daylight it also has a tungsten LEDs as well. So it has an electricity board that you'll see in the end. Everything is being wired and sits nicely, and every, of course, LED strip has its own dimmer. Everything is based with power supplies from laptops, because they don't need fans and they're small in size. So you see it in the end of this video. In this build, we are adding 4 strips of LED in each side of this piece of aluminum. So now on number 3, and in the end, of course, it will be, as you see here, 4 in each side. In the middle there is the holes that we're going to mount it to the ceiling. And now I'm starting the other side. Again, the LED strip are just and sits in the edge of this aluminum. And after that, of course, I'm taping the next wall and so on, until in the end we'll have 8 LED strips altogether. The consumption concerning amp in this build here is about 10.5 amps, so and 12.5 amps power supply, of course, will do the trick here. And since I told you before we're using power supply from laptops, I'm using a 19.5 volts from Dell, which is the biggest power supply I could find from laptops, and of course we'll need also a step down converter in order to convert this 19.5 volts to 12 volts, which the LED strip used. And here, as you see, I'm taping a isolation tape to the aluminum in order to put here the wiring so it won't short circuit the whole thing. I came up with this idea doing this build. So I'm taking a 1.5 electricity wire, as you can see here, cutting out the insulation, and this wire will be taped to the insulation, as you'll see in a minute. And to that wire, of course, we're gonna solder out the whole connection to these LEDs. So now I'm taking another wire and cutting out the insulation, of course make it in the right fit, so it will fit from the LED strip to the wiring that we're going to solder it to. After measuring and bending it to the right place, I'm cutting it with a cutter and of course applying the flux on all the connection, as this is the next step. After that, of course, putting a bit of solder in each connection. Now, as you can see, since this is blue, then we are here making the connection for the minus, and the other end, of course, of this panel will connect the plus. So just putting it on the minus. Again, this is the trick, and now again dumping this wire here in the same solution so it will stick easily, as you can see here, and soldering out to the LED strip and then to our connection wire in the end. Now, as you can see in this example, since the wire was a bit longer, then it's not a problem. Of course, we can take the cutter and cut the extra wire out. And repeating the same step in all connections until, of course, we'll finish this side. Now as we finish here, we're going to do the other side, and of course this will be to connect the plus of this circuit. Again, the same process as we did in the minus side, and isolation tape. And here, besides putting the isolation tape, since this is the plus, I decided to leave the wire with the insulation in all the connection. You'll see in a minute. So this first step looks exactly the same. I'm just taping it so it won't move. But now, instead of taking the whole isolation from each wire that connected to the back wire, I'm leaving, as you see here, the insulation. So again, if something will touch the surface of this aluminum, we won't have a short circuit because of it. Now, after finishing this last wire, I came to an idea that I will, instead of making a wire from each side, the minus to the plus, I will just wire the whole thing to the aluminum, which looks promising. I didn't thought that the real solder will work, but it did. And here I'm testing it so to see it's working, and it's working. But in the end, the whole thing didn't work. So after installing it, and here I'm just putting a hot glue to all connections so it will be tight and close, and also act as isolation. Anyhow, in the end I ran a 1.5 wire from one end, this blue end, to the other side in order to connect it to the whole circuit, because as though the aluminum connection was fine, when it got hot, the whole thing getting hot, this connection broke. So don't do this mistake. So just connect it with regular wire instead of using the aluminum as a conductor, which I thought would be a great idea. But again, real soldering won't catch the aluminum as good as it needs to be. And since everything like metal which get hot, it expand and extract, the connection lost. And I got in flickering light because of it until it didn't work at all. So after figuring out that was the problem, I again ran a blue wire from the one end to the other one, and then of course this fixed the problem because both wires were connected directly instead of using aluminum. Again, before we closing, I'm doing another test here to see that it works. And this is the power supply I was talked about. This is the 240 watts Dell power supply, which give us 19.79 volt. And here, of course, after checking the power supply is working, I'm cutting out the connection since we don't need it. You should know this power supply is coming with 3 wire inside. It's also giving 5 volts to the laptops, which you don't need here, of course. So both wires that we need are the most thicker ones, which are colored in black and white. The white is the plus and the minus is the black. And the green here is the 5 volt plus, which we don't need, so we can just cut it out. What I'm doing now is basically connecting it to a step down converter. This unit basically take any volts from let's say 0 to 30 and can take it down to any voltage you need. By default it comes dialed to 5.5 volt. So again, putting the input and output goes to our dimmer. As you can see, I'm just cutting a 2 wire, black and red, and connected to the input of the dimmer, and of course taking the output of the dimmer again with wire. The whole thing I'm doing now is just for testing. Again, it's not for the installation itself on the place that we need to install it. I'm just testing it here to see if everything works. So again, connecting the output of this dimmer, which will then be connected to the 2 wire we solder out to the LED panel. So the next step of course will be to dial the whole thing to the right voltage. So taking the measurement voltmeter and then starting to test. So first test of course will be the input of the power supply, 19.79, And the output of this step-down converter, as I told you, it's 5.39, which is very low. We need to crank it a bit up. So I'm taking a screwdriver and turning this knob here, and which will increase the voltage output from this device until it will reach 15.10. But you can say, and then testing, of course, the input of the dimmer and the output of the dimmer. Again, nothing is connected now, so there is no load on the system. And then taking the potentiometer of the dimmer and trying to see if there is any difference when I turn it off and on, which eventually showed nothing, because this dimmer, unlike other dimmers, doesn't change the voltage. It's changing the current of this unit. So voltmeter won't show you anything, which I figured out eventually. So this didn't give me any reading, so I decided to leave it as it is. Now if you're asking yourself why the hell I'm putting it on 15.5 when the LED strip is 12, or if I won't burn it up, and then the answer is no, because when this LED strip is connected, the step-down converter is falling in voltage. So as you see, it just got 10.13 volts on the LED strip, although we dial it to 15. So it's, directly with the load, it's going down to 10.5. Anyhow, the dimmer, now I'm cutting the two wires that are connected to this potentiometer, because this potentiometer also acts as an on-off switch, which we don't need. So I'm just connecting this black and red wire together. So I'm basically bypassing the on-off switch on the dimmer itself, on the potentiometer. Again, I could use it, but it means that I need to also make two wire longer, because I need to make an extension cord to this whole wiring. And since I don't need the on-off switch, because I have an on-off switch on the circuit I'm building, then this can be always on. So again, soldering it, and with isolation shrink, it will be shrink in a minute, just covering it up. Now we need to cut the three other wires of this potentiometer in order to make them longer, because in the places it will be sits inside this board that I built, it can't sit so nearby. So as I'm all about recycling, as you can see, this is a piece of wire that came from a power supply of desktop. Just taking the wires from that. It's a power supply that doesn't work, so just cut the wiring and use it here in this project. Since it's the same thickness as this dimmer, even a bit higher than this dimmer, but it's still good enough. The more the thickness is, the better. Although this is only command voltage, so it doesn't need to be so thick. Anyhow, again, as you can see, soldering it out and closing with a heat shrink. And after that, of course, shrinking it with a shrink gun to finish the whole wiring thing. Again, I'm connecting it in both ends. This is the side of the dimmer, and here in the side of the potentiometer. Again, I could connect it directly, but since you see that it's coming from the manufacturer with a hot heat shrink on the end, I decided to connect it this way. Just want to add that I'm using these dimmers for a long time, and now they are the best I could find. The only one that rated for 30 amps. And that really works, and as well as all the other equipment. I will keep, of course, links in the description below this video, so you can order the same if you want to build this type of project. Next step will be to take the shrink gun and shrink all the places that need to be shrink, as you can see me doing here. Now I'm soldering the end of the power supply, because as I remember before, we just did for the test, I didn't put any soldering, so doing it right now. And with a band, just tie up the whole free wiring, so it won't stumble into other wiring inside the board that you're going to install it. Now we need to change the cooling aluminum piece that came with the step-down converter to a bigger ones. And if you're asking yourself why, because the one that came with it can only support about 6 amps, and since we need 10, the manufacturer says that above 8 we need to change them to a bigger one. So basically I'm taking the one that came with the unit out, and you see here the big piece of aluminum that I'm going to use is again pieces that I turn up from motherboards of computers. These units came to cool down a chip that was on the board itself. So since I have a few of them, which will just the right size, I'm just taking the one that came with it, mark it with a pen where to drill the hole, because it needs to be connected to this device here. So with a pen marking where to drill, and of course the same as we did before, we're drilling with 2.5mm drill in order to make the hole, as you remember, which will be free with screwing, of course, the tap screwing. So again, 2.5mm as a first step, and after that, of course, with a thread we'll make the screwing for the screw. In the build, in the end, you'll see that I use a different size of heat cooling unit. I took the one that you'll see in the end from, again, all came from computers. It was for Pentium 2, if you remember, and Pentium 1 even. I just had lying down a few cooling units from old computers, so I decided to use them as a cooling unit for this step-down converter. Now, connecting the first side, you said, okay, that's not a problem, but how the hell are you going to connect the other side? Because you can't put a screwdriver inside, because, yeah. So here's the solution. So I'm taking a drill, the same 2.5 drill, just mark where I need to drill a hole so I can put a screwdriver in order to screw the other side. So that was my idea in order to overcome this problem, because I do have a 90 degrees connection for screws, but since this whole thing is very, very small, none of this device that you may buy online or whatever can fit this small stuff. So just mark it, unscrew the screw that hold this unit, and now of course I'm gonna drill with number 5.5, and if you want bigger you can take number 6, depends on your screwdriver of course. And now I'm just drilling the hole so we can put the screwdriver inside and then close the other side. And now after this is closed, we can take the other side, of course, enter our screwdriver in the hole that we just drilled and easily close the other side. So this is how it looks in the end. Both cooling units are connected to the step-down converter. Now we're jumping to the studio. So here you can see me connecting this step-down converter on top of the electricity board which I built, because there is no more place inside. Thinking about changing the power supply to something else, but in the meantime that's the only option. Now you can see in the mirror in the left side soldering the cable coming from this electricity board directly to the LED strip we just built. And of course after that closing it with a heat shrink and closing the tab that we just built with the perspex as to cover up the whole connection so it will look nice and clean. Next step of course will be to connect it to the ceiling. Now in order to prevent this whole step-down converter unit to move, since I didn't have any place to mount it to the screws, I decided to take a double-sided tape and tape it to the electricity board. And now start the tour. So this is the electricity board you saw before. This is the on-off switch, which basically turns on the electricity to the whole thing. It's connected to a relay, step relay. So here you see the power supplies. This again is the power supplies All of them are the same. The Dell one you see here is above. I just figured out I could buy the Dell, which is smaller in size, but the bigger one are exactly the same voltage and amps. Here are all the step-down converter with the bigger heat cooling unit. This is the Pentium 2 and Pentium 1 I talked about. And here is the device we just installed. The step-down which sits on the top of this electricity board, and now you have a tour in the studio. So this is the rails and everything, and here you have an Sennheiser ME66 inside this device. This is the D.I.Y I was talking about, which I built also. Again, it has a mirror and all the lights, which give you a wonderful effect of the D.I.Y, a square one instead of a round one. All the wiring goes up here and go out to each LED strip. So we have here on the top one which is sits with rails. As you see, this again was the first thing I built in order to be a top light. Now the two side lights here again fitting on the same aluminum that we just built as an extra one. Okay, this is for the side light, and as you see on the ceiling now, the one everything is moved on rails, and you can turn it in every side you want. And this is the one we just built, which is fixed to the ceiling, just to give an extra light here. And again, everything can move easily. And again, the whole board has, as I told you, dimmer for a daylight and also for the tungsten. And this is the dimmer that you see here. And if we close it, that's about it. Hope you enjoyed this video.